Hello students, Stride here. Today we're starting in Chapter 10, the mole. As we cover Chapter 10, today we'll be working on Section 1, Measuring Matter. As we continue, we'll do Section 2, Mass in the mole, Section 3, Moles of Compounds, Section 4, Empirical Molecular Formulas, Section 5, Formulas of Hydrates. In Section 1, your objectives will be you'll need to know how a mole is used indirectly to count the number of particles of matter. Going to relate the mole to common everyday units. And we're going to convert, this is the big one, between moles and numbers of represented particles. That's the really important one. Review vocab. You realize the molecule, two or more atoms covalently bonded together. New vocab will get mole and Avogadro's number. The main idea, chemists use the mole to count number of atoms, molecules, ions, and formula units. Because the atom ions are such small quantities, we need a convenient method for accurately counting these, and the mole works out great for this. Mole, here's our definition, SI base unit used to measure the amount of a substance. It is the amount of atoms in 12 grams of pure carbon-12. Turns out to be 6.02 times 10 to the 23rd particles. We will be using 6.022 times 10 to the 23rd, just adding one more sig fig on it. And representative particles can be atoms, molecules, formula units, electrons, ions, and other things. And then this number, 6.022 times 10 to the 23rd, is called Avogadro's number. And we're going to do conversions, be similar to some stuff we've done in the past. Here we're going to be finding the number of molecules in 3.5 moles of sucrose. Now, the way I write it down will be slightly different, but we're trying to change from the 3.5 moles of sucrose into molecules. So we start with 3.50 moles of sucrose. And we're trying to change from moles to molecules. And 1 mole is 6.022 times 10 to the 23rd molecules. Do a calculation, the moles cancel here. With molecules of sucrose, calculation, get to keep 3 sig figs, and it turns out to be 2.11 times 10 to the 24th. We will do some more of this type of work on the next video, where I'll just concentrate on the calculation part of it. And here we want to go from particles to moles. And if we had that same number we had there before, the 2.11 times 10 to the 24th molecules of sucrose. And we know 1 1 mole of sucrose is 6.022 times 10 to the 23rd molecules of sucrose. I don't have room to write that out, but that would be written there. I'll just put M as molecules of sucrose. The 10 to the 23rd, we cancel out 10 to 24th, just leaving us a 10. So now the 2.11 calculations here would be 2.11 times 10 divided by 6.022. And when we do all that, it gives us the 3.50 moles of sucrose. Yeah, a little quick review question. What does the mole measure? And that is, as it shows here, the amount of a substance. And conversion factor to determine number of moles of a substance from number of particles. So if we're trying to go from particles to moles, if we write it out as in my little system here, trying to go, so we're starting with particles. So we're going from particles to moles. That has to be that one right there. So, quick overview of section 10.1. If you read the section, you can write down any other additional things that you didn't get here, or you seem to be important to you. Write them down, record your notes, submit me a photo. So, that's it for now.